Okay, so what we're looking at here again is another rate of change calculation, and this one relates to speed and acceleration. So speed and acceleration. So if we just read through the question, so a body moves along a straight line and its distance, so this small s is distance and the unit is meters. So remember, always make note of the unit. From a fixed point on the line after t seconds, so time is in seconds, is given by, so it's given by this this function here. So this s, this means distance. So remember this s. So distance is equal to 3 times 3t cubed minus 4t plus 6. And t is time, which is in seconds, and this s represents distance, which is in meters. So what we can do with this is we can take time, we can plug it into this formula, and it'll give us, so let's say after 2 seconds, we could put that time into this formula, and it'll tell us the distance this body has moved at that time. Now the question, what it asks you to do is, it's speed after t seconds. Now the way to kind of think about this is, so this will tell you, this function tells you how far it travels after a particular amount of time. Now if we think about speed, speed is going to be, in order to get the speed, we have to get the second derivative of this. So speed is a way to think about it is, it's the rate of change of distance with respect to time. So we have to get the first derivative of this. So what we can do is we can do that. So we'll just have a look at that first of all. So s, which is distance, is equal to 3 times t to be cubed minus 4 times t plus 6. So what we have to do is we have to differentiate this, and we just use what we've learned in class. So it's going to be 3. So again, we look at each term and we need to differentiate each term. So what we're saying is that, so ds, dt, so this is the rate of change of distance with respect to time, is going to be equal to, so we have to differentiate this, so it's going to be so the power multiplied by the coefficient, and then we reduce the power by 1. So what does that look like? Like it's 3 by 3, which is 9. So it's going to be 9t, and then we have the minus 1 from the power, which will leave us with not 9t to the power of 2 minus, so remember we have, so 4t, so this means, so this is 4t to the power of 1. So we multiply the power by the number and then reduce the power. So that will just leave us with, so that just differentiate into 4. And then this here, so again remember, so 6, so it means 6 to the power of 1. So it's, and there's a 1 in front of here, so it's 1 by 1, and then we reduce this by, so this just drops off. So if we take this guy here and we differentiate it, we get 9t2 minus 4. So what this tells us then, this is the rate of change of distance with respect to time. And another word for this is speed. So this actually, so ds dt, this is speed. So speed is equal to ds dt, which is equal to this function here. And this tells us how we figure out the rate of change or speed at a particular time. So this is the answer to the first part. So what you can actually say is that speed is equal to, you can write it like this, 9t to the power of 2 minus 4 meters per second, like so. So that just means that for any given time, you can just put it in here, you work this out, and it'll give you the speed in meters per second. So that's the first part. So this here is the answer. It's the answer to this first part here. The second part then, it asks you, so it's what is its speed after 2 seconds? So basically what we're saying is, so when t is 2 seconds, what's the speed? So we have to take this formula here that we've derived, and we have to substitute in the value for t. So this is question 1. So then question 2 then, I will just push this up. So question 2 is just, we're going to take this, so 9t to the power of 2 minus 4, and we're going to let t equal 2 seconds. So what we have to do is we have to take this value for 2 and substitute it into this formula. So what it means is that wherever there's a t there, you replace it with 2. So what does that look like? So it's going to be 9 multiplied by 2 to the power of 2 minus 4. So again, we have to do the index first. So this is going to be 9 multiplied by 2 is 4 minus 4. So 4 9s. So 9 and 9 is 18, and 18 and 18 is 36. So that's going to be 36 minus 4. So 36 minus 4 is equal to 32. And we use the units of speed. So it's going to be 32 meters per second. So 32 meters per second. So again, the question asks, so what is its speed after 2 seconds? We take the value for 2, we substitute it into this expression that we've derived. We work it out, so we've worked it out, and we found out that it's 36 minus 4, so it's 32 meters per second. So so we've done question 1, part 1, we've done part 2. So the next one is, after how many seconds the body is at rest? So remember, what we're talking about then is it's going to be a maximum or a minimum. So what we're really doing is, with this, we're trying to figure out, so this here tells us the rate of change. So we're trying to figure out, when does this expression, at what time will this expression be equal to 0? So this is the speed, or the change of distance in relation to time, or another way to think about it is, this is the slope. So what we have to do is, we have to let this equal to 0. So we take this expression and we let it equal to 0, and then we work out and solve for t. So if we take part 3, so what we're saying is, we're going to let this expression 9t to the power of 2 minus 4, we're going to let it equal to 0. So after how many seconds the body is at rest? So when the body's at rest, there's going to be 0 speed. So we have to then solve for time. We're going to figure out what time will that be at. So we have to solve for t. So the first thing we want to do is, we want to get rid of all of these numbers that are around t. So we start with this here, with the minus 4. So we think about, what do we have to do to minus 4 to turn it to 0? We have to add 4. So this is minus 4, so we have to add 4. If we add 4 on this side, we have to add 4 on this side. So this then becomes 9t to the power of 2. So these two cancel out. 9t to the power of 2 is equal to 4. So this is 9 multiplied by t. So we look at this and we have to think about, what do I have to do to this to cancel or get rid of the 9? So because this is 9 multiplied by t, we have to do the opposite of multiplication, which is division. So we have to divide this by 9. If we divide this side by 9, we have to divide this side by 9. So these two guys will cancel out, and you'll be left with t squared is equal to 4 over 9. So 4 over 9, like so. Now what we want to do is, we want to get rid of this power here. So if we think about power, the opposite of a power is a square root. So in order to get rid of this power, we have to square it. So we get the square root of this. If I get the square root of this side, I have to get the square root of this side, like so. So what this will enable us to do is, this will cancel out the square, like so, and you'll just be left with time is equal to, so when we get the square root of a fraction, we get the square of the top number and the square of the bottom number. So the square root of 4 is equal to 2 over the square root of 9, which is equal to 3. So this is your answer. So the time is 2 over 3 seconds. So what we can say is, so if we go back to the original question, so after how many seconds the body is at rest? So after 2/3 of a second, the body is at rest. So that's your answer to that one. And then if we look at the next one then, so we want to work out its acceleration. And I'm just going to do that here. So let me just draw a line here. Now, in order to get acceleration, so if this expression, so this expression just describes the relationship between distance and time. When we got the first derivative of this, we got speed. Okay, so that tells us speed is this here. Now, if we want to figure out what acceleration is, and we have the formula, for example, to get speed, which is this one here, what we can do is we can get the derivative of this, or what's known as the second derivative, and this will give us acceleration. So if ds, so a way to kind of look at this then is, so if ds dt is equal to 9t to the power of 2 minus 4, so if that's what speed is, or ds dt, we want to get the second derivative, and that will actually tell us what acceleration is. So the second derivative is going to be d squared s over dt s, like so. Sorry, dt squared, that should be dt squared. So essentially what we're doing is we're taking this first derivative and we're deriving it again. So again, we carry out our process. So it's the power multiplied by the coefficient, and then we drop the power by 1. So it's 2 nines is 18. And then we minus 1 from the power, so that just leaves it as 18t. So this guy here, so it's going to be 4 to the power of 1 multiplied by this, and then we drop it, that becomes 4 to the power of minus 4 to the power of 0, so that just drops off. So this is the first derivative, then the second derivative is this here. And the second derivative, that tells us what acceleration is. So acceleration, in this case, acceleration is going to be equal to 18 times t. And remember, these two things mean the same thing. So acceleration is 18t. So what it asks us to, the question, so part 4, it asks us what is its acceleration after 3 seconds. So we go back down here, and when t is equal to 3, we want to find out what the acceleration is. So what we have to do is we take this value and we substitute it into this expression here. So it's going to be 18 times 3. And 3 18s is equal to 54. And it's going to be meters per second. Now, if we take, so if the first derivative, so if we look at the first derivative, which is speed, and that's in 32 meters per second, okay, so that's to the power of 1. The second derivative then is going to be the same, it's going to be this same, like it's going to be meters per second, but it's meters per second, so it's going to be to the power of 2. The second derivative will be to the power of 2. So what we can say is that the acceleration at, when the time is 3 seconds, it's going to be 54 meters per second. And that's your answer. That's your answer there. So again, these are common questions that come up in the Leaving Cert. And we're looking at rates of change. And in this case, we're looking at speed and acceleration.